In today's lesson, we'll learn how to use what we already know about right triangles, isosceles triangles, and equilateral triangles. How to use what we already know about those triangle types to help us figure out the measure of missing angles. So let's just begin by reviewing what we know about these different types of triangles. So let's start with a right triangle. We know that in a right triangle, there is one right angle, and that small little box in the corner shows us that it's a right angle. And we know that that angle measure is 90 degrees. Okay, so we know that about a right angle. Let's review what we know about an isosceles triangle. An isosceles has two sides the same length. And the way that we remembered that when we were going through that is we know that the two S's in isosceles reminds us that it has two side lengths the same measure. And those single tick marks on each of the sides tells us that those are the two sides that have the same length. So isosceles triangles have two sides the same length. And an equilateral triangle has all sides equal. So when it has the three single tick marks, that tells us that all sides are equal. So equilateral triangle, all sides equal. Now that we've reviewed what we know about those different types of triangles, right triangles, isosceles triangles, and equilateral triangles, let's apply it to figure out more about angle measures. So the first thing we're going to start with is right angles or right triangles. So we're going to show that the sum of the measures of the two acute angles in a right triangle is 90 degrees. So what does that mean? Well, let's look at this right triangle first. We know that this is a right triangle because it has that little square in the corner. And so we know that the measure of angle B is going to be 90 degrees because we know a right angle is 90 degrees. So what this is saying, what this rule is saying, is that when you have a right triangle, the sum of the other two acute angles, so the other two acute angles are angle A and angle C. The sum of those two angle measures is going to be 90 degrees. Now, why is that? Because we know that the whole triangle, right, all the angles when added together, we learned yesterday that the total sum of all angles in a triangle has to be 180. So in a right triangle, we know that one of those angles is 90 degrees. So the other two acute angles have to have a combined sum of 90 degrees because 90 plus 90 is 180. So the sum of the two acute angles in a right triangle has to have a sum of 90 degrees. So let's explore this a little bit further in this triangle, triangle A, C, B, okay, or ABC. We can see that angle A is the right angle. So we can see angle A is the right angle. We know that is 90 degrees. The other two acute angles are going to have a combined sum of 90 degrees. We know that the total measure of all the angles in a triangle have to be 180. So when we have a right triangle, we know that one of the angles is 90 degrees because it's a right triangle. The other two acute angles must have a sum of 90 degrees because the total angle measures have to be 180. So what do we know in looking at this triangle? We know the 90 degrees. We are also given the measure of angle B, which is 60. So I know 60 plus an unknown angle measure, angle C, right, have to have a total measure of 90 degrees. So these two together have to be equal to 90 degrees. So I can ask myself, 60 plus what would give me 90? Well, I know 60 plus 30 is 90. So that tells me that the measure of angle C must be 30 degrees. Okay, your turn. Let's try this number 1 together. It says these triangles are not drawn to scale, and you need to find the unknown angle measures. So let's look at triangle LNM. And the missing measure we can see is angle M. That's our question mark. We know that all three angles together must total 180 degrees. We have a right triangle, so we know that one of the angle measures is 90. The other two acute angle measures must have a combined sum of 90 degrees, and that way all three angles will equal 180 degrees. We're given one of the angles, which is 73. So how are we going to find the missing angle, angle M? Pause the video, show your thinking, and then see if your angle M measure matches mine. Okay, so one of the ways we could do it is we could take 90 minus 73, and that would give us the missing amount. So when I subtract 90 or 73 from 90, I get 17 degrees. So the angle measure for M would be 17 degrees. Now you can always check this. You can always say, okay, well 90 plus 73 plus 17. Does that give me 180? Well, 7 plus 3 is 10. 9 plus 1 is 10. Plus 7 is 17. Plus 1 is 180. So it does check out. And so the missing angle M, is 17 degrees. All right, your turn to try number 2 on your own. Will you find the missing angle T, knowing that this is a right triangle, using that knowledge of what we know about right triangles, find the missing angle T. So let's start off with what we know. We know that the three angle measures in a triangle must have a total measure of 180. And because we know that it is a right triangle, we know that one of those angles is 90 degrees. So to find the missing angles, we know the missing, or the two acute angles, must have a total measure of 90, and we're given one of those of having a measure of 45 degrees. So the missing angle T would have to be 45 degrees, because 45 plus 45 is 90. So another way of thinking about it would be to say 90 minus 45, and we still get 45 degrees for the missing angle. Next, we're going to explore isosceles triangles a little bit more carefully. And remember that isosceles triangles have two sides the same length. Those two S's in isosceles reminds us that an isosceles triangle has two sides the same length. And we can see that with the single tick marks. Those single tick marks tell us that these two sides have the same length. So it is an isosceles triangle. Now, if we were to draw a line of symmetry, as they've done down here, and we were to visually picture that side folding over, you can see that angle C, when it's folded over to lay on top of angle B, that angle B and angle C have an equivalent measure, or an equal measure. So here's the rule for isosceles triangles. In an isosceles triangle, the measures of the angles opposite the equal side. So if these two are my equal sides, these two angle measures will be equal. So we're going to use that now to help us find missing angle measures in isosceles triangle. All right, let's look at triangle ABC. We can see right off the bat that it's an isosceles triangle because those two tick marks, we can see that AC, the length of AC, is equal to the length of BC. And so we know that the opposite angle measures of these two equivalent sides is they're going to have equal measures. So without doing any math problem solving, I can tell what the measure of angle A is going to be because it is equal to the measure of angle B. So we know that angle A is going to be 62 degrees. So we have found the measure for angle A. Now let's talk about how we can find the measure for angle C. Well, I also know that all three angles in a triangle must have a sum of 180 degrees. I know that two of the angles or angle measures are 62 degrees. I need to find the missing angle C. So if I add 62 plus 62, that would give me the total measure of angles A and B, which is 124 degrees. And now to find the missing angle measure, I would just need to take the total, 180, and subtract 124. And I can see that missing angle measure, angle C, is going to be 56 degrees. Now, we can always check it, right? We could add 62 plus 62 plus 56. And if we were right, our total should be 180. So 6 plus 2 is 8, plus 2 is 10. 6 plus 6 is 12, plus 1 is 13, plus 5 is 18. We were correct. Now let's look at another scenario when related to isosceles triangles. So we can see that the isosceles triangle, it's isosceles because we have line FD that is equivalent to line DE. So those two lines have the same measure. That tells me that angle F and angle E are going to have equal angle measures. But they don't give me angle F or angle E. They only give me angle D. So let's look at what we know, okay? We know that all three angles in a triangle have to have a sum of 180 degrees. The other thing that I know is that one of those angles is 78 degrees. And the other piece I know is that angle E and angle F must be equal in size. So it has to be an equal amount. So think about how you would solve that. Well, one way to think about it is if we were to take 180 and take away the angle that we know, 78 degrees, we are left with a measure of 102 degrees. So we know that between angle E and angle F, they have to have 102 degrees total. And they have to be equal in measurement. So I'm going to have to take those 102 degrees and divide it equally among the two angles. So 2 goes into 10 5 times. 2 goes into 2 once. And so I can see that each of these angles will have to have a measure of 51 degrees because they have to be equal in size. So rid of this. Exactly what we said, 102 divided by 2. We see that each of the angle measures would be 51 degrees. And again, we could check this. 78 plus 51 plus 51, 8, 9, 10. 7 plus 1 is 8, plus 5 is 13, plus 5 is 18. So a total measure of 180 degrees. All right, your turn. Will you look at triangle ABC and notice first that it's an isosceles triangle? Think about that, what that tells you about the angle measures. See what angle measures you're given, and then will you find the measure of angle A? Check back to see if your thinking matches. All right, so because I know this is an isosceles triangle, I know the opposite angles of the opposite equivalent sides have to be equal in measure. So I automatically know that angle B is going to be 39 degrees. So now I know that I have two angles with the measure of 39, and the missing angle that I'm trying to find is angle A. So what is the plan for solving this? Well, let's find the total of those two angle measures, 39 degrees plus 39 degrees. And I can see their total measure is 78 degrees. So to find the angle measure of A, I would have to take, I could take 180 minus 39 minus 39. I know that this amount is 78, so I'm going to take 180 minus 78, and the missing angle measure would be 102 degrees. Again, you know me, I like to double check, so let's just make sure that all three of these angles have a total measure of 180. 9 plus 9 is, ooh, we made a mistake somewhere. Let me come back and check. All right, so 180 minus 78. And 39 plus 39 is 18. Plus, so 78. All right, so this just shows you that teachers aren't perfect either. I was so determined to find what my error was, though, and I want you to see that math is not always perfect, so I didn't even remake that little clip. Look what I did. You probably saw it. This missing angle measure was not 120, it was 102. Ugh, my old eyes. Okay, so let's try it again. 102 plus 39 plus 39. Let's see if that gets us to 180. All right, 9 plus 2 is 10. 11. Plus 9 is 20. 3 plus 3 is 2 3 plus 3 is 6 plus 2, 8 and 1. So yes, that is correct. So the missing angle is 102. It is not 120. All right, the last kind of triangle we're going to look at is an equilateral triangle. And when we have an equilateral triangle, we know that all sides are equal, all side lengths are equal. And so when all side lengths are equal, that tells us that the measure of all angles in an equilateral triangle are also equal. So the measure of z, x, and y all have to have an equal measure. So what does that mean? Well, we know that all angles in a triangle have to have a sum, or when combined, have a sum of 180 degrees. So I would need to divide 180 degrees equally between the three angles. So when divided into 3 equal groups, we get 60 degrees. So each angle measure in an equilateral triangle is 60 degrees. Always. It's a rule. So each angle in an equilateral triangle measures 60. So now I want you to use what we've just talked about, that in an equilateral triangle, all angle measures are 60 degrees. And I want you to see if you can find the 2 equilateral triangles in this grouping. Pause the video, reason through it, and then be able to defend your choices of which triangles were equilateral triangles. All right, let's go one by one. Let's start with the yellow triangle. Yellow triangle, equilateral or not equilateral? Well, we can see that 2 of the angle measures are 60 degrees. So if we have 60 degrees plus 60 degrees, that gives us a total of 120 degrees. And we know that all 3 angles must have a sum of 180. So 180 minus 120 would give us 60 degrees. So that missing angle B has to be 60 degrees. So the yellow triangle is an equilateral triangle. Let's move on to the green triangle. We can see one angle measure is 60 degrees, one angle measure is 70 degrees. That there alone tells us it is not equilateral because we know all 3 angles have to be 60 degrees. So triangle green, the green triangle is not equilateral. Okay, let's look at triangle L and M. We can see that this is definitely an isosceles triangle. We can see that one angle measure is 60. Because it's isosceles, we know that angle M has to be 60 because in an isosceles triangle, opposite angles of the equivalent sides have to be the same measure. So because angle M is 60, it also tells us that angle L has to be 60 degrees. So the red triangle is an equilateral. Finally, we have the blue triangle. The first thing you probably noticed is that we have a right angle, and the right triangle tells us that one of the angle measures is 90 degrees and therefore cannot be equilateral, since in an equilateral triangle you have to have 3 angle measures of 60 degrees. All right, now the fun part. This is where you get to solve, they're kind of like puzzles, I think. Solve some triangle puzzles, figuring out what the missing angles are based on what we learned today, knowing that in a right triangle, the 2 acute triangles must have a combined sum of 90 degrees, knowing that in an isosceles triangle, the opposite angles of the equivalent sides have to have equal angle measures, and knowing that in an equivalent triangle, that all 3 angles must be 60 degrees. All right, so combining all of that, we're going to find some missing angles. So let's look at triangle ABC. They would like for us to find the measure of angle CAD. So angle CAD is right there highlighted in yellow. So let's look to see what we know about this triangle. First, we know it's an equilateral triangle, ABC. So this outer triangle, ABC, is an equilateral triangle, telling us that each angle measure is going to be 60 degrees. And so how are we going to use that to help us figure out this missing angle? Well, we do have a line of symmetry drawn, correct? And so how could that help us to figure out the missing angle? Well, if this whole angle is 60 degrees, right? Because angle A has to be 60 degrees. What would be half of 60? Because this line is cutting it in half. Well, this side would have to be 30, and this side would have to be 30, giving us the whole angle measure of 60 degrees. So the measure of CAD would be 30 degrees. Now, another thing you could have used to help us figure that out is understanding that if this is a right angle over here, then this also forms a right angle over here, telling us that this is 90 degrees. So now in the triangle ACD, we know that one angle measure is 60 degrees. Oops, grab the highlighter. So one angle measure is 60 degrees. One angle measure is 90 degrees. And so the missing angle measure can be found by subtracting those two known amounts from 180. So 60 plus 90 I know is 150, and 150 minus 180 is 30 degrees. See how these are kind of like number puzzles, figuring out the unknown? Okay, so just to recap, in today's lesson, we learned that in a right triangle, the sum of the measures of the two acute angles has to have a total of 90 degrees. We also learned that in an isosceles triangle, the measures of the angles opposite the equal sides are equal in length, are equal in measure. So the angles have equal measures. And finally, we learned that in an equilateral triangle, all angle measures must be 60 degrees. That all angles of an equilateral triangle are equal.